Good morning, students. We have continued with acid, bases, and salts. Okay. So, what is the salt? We have learned acid and bases, but we left with salts. So, what is the salts? Salt is nothing but the neutralizing product of acids and bases. Okay. So, if we react with HCl with NaOH, we have NaCl, and that is salt. So, salt is nothing but the neutralizing product of acids and bases. Okay. You can see like this, or you can say like this: the salts that formed by combination of alkali metal or any metal with the halogen or any other acidic ion. Okay, any other acidic ion, or you can see you can say anion. Okay, so any metal, for example sodium metal, if combined with any halogen like iodine, they get form sodium iodide. If I take the example of potassium with bromine, we have potassium bromide. Okay, if I take calcium, we have combined with chlorine, we have calcium chloride. So students, since the calcium is the member of second group, so second group calcium has valency +2, therefore it forms 2 chlorides ion, okay, on its salts. Now if I add some more salts like sodium carbonate, okay, we cannot say it's salt, sorry. We have like magnesium chloride, MgCl2, we have FeCl3, this is also salt of ferric hydroxide and HCl. Okay, we have some more salts like potassium nitrate, potassium sulfate, sodium sulfate, sodium sulfide, etc. We have these more and more example of, so much example of, you can say, these salts. Okay, those salts are nothing but that formed by combination of metal, any metal with the halogen like chlorine, bromine, iodine, or any other acidic ion. I can see acidic ion, what is called anion, like sulfate, nitrate, sulfide, or carbonate. Okay, we cannot say by carbonate, but these all are the salts. Okay, fine students. And properties of salt. We have properties of salts. Okay, so first, all salt, not all salt, but generally this substance which have pH is equal to 7, this is not correct. Many salts are water soluble. Okay. Why I say many salts are water soluble? Because some salts are in water, they not completely soluble, but they have sparingly soluble, like silver chloride, AgCl. Okay. This is a water insoluble salt, but many salts are water soluble, like potassium chloride, sodium chloride. You have table salt, that is sodium chloride, potassium bromide, potassium iodide, potassium nitrate, sodium sulfate, sodium sulfide, sodium sulfide. These all are the water soluble salts. Okay. And second property is, some salts are in hygroscopic in nature. Okay, what is hygroscopic? Hygroscopic is nothing but property that have, if you take salt and you keep it open, this salt accumulates some moisture from the air or from the atmosphere and becomes like semi-solids. In some semi-solid, like some salts get dissolved or some get melted and some salts left behind. That is called the hygroscopic in nature. The generally salts which absorb moisture and become semi-solid, that is called the hygroscopic. Okay. Third, all salts are in solid state. Okay. You well know that all salts are in solid state. Okay. Fourth, generally salts are ionic in nature. I say not all salt, but generally salts are the ionic in nature and they have ionic bond. Okay. Fifth, salts many salts are water soluble, hygroscopic, ionic. Fifth, okay, fine. Generally, salts have higher melting point. Okay, higher melting point, like if I take example of sodium chloride, it has melting point of 800 to 900 degrees centigrade. Okay, because of covalency and they form the strong lattice structure, they are high, they have higher boiling point like 800 900 degrees centigrade. Okay, and I take the fifth, not fifth, that is sixth. Salts are true solid. Okay, true solid, or you can say crystalline solid. What is crystalline solid? Crystalline solid is crystal like compound. What is crystal? Crystal that have well developed the geometry, okay, well known geometry, and they have geometry, or you can say the arrangement of atom in that in well manner, okay, or shape and size is definable, that is called the crystalline solid, okay. Fine students, so this is all about of salts, okay. So now I take next topic, that is concept of pH, okay. Fine students, concept of pH. What is pH? pH is, you can see, minus logarithm of H plus ion concentration, okay. If I say the compound is acidic, basic or neutral, you can identify it by knowing the pH value of them, okay. So if I say I have some chemical that possesses pH 7.4. What is the nature? Nature you can just say this is the alkaline. How? See, from 0 to 6.99, and from this is 7, and if you go above 7.1 to 40, this is basic, okay. If I have pH is equal to 7, this is called neutral. If I have pH between 0 to 6.99, the solution becomes acidic, okay. See here. So students, this is the pH value of some solution like acidic, basic or neutral. If I say you the solution has pH value of 9, so what is the nature of that solution? You can just easily say this is basic, because 9 falls under category between 7 to 40, okay. If I have pH value like 3, you can say this is acidic, and all neutral solution like water and salts, they possess pH value 7, okay. They all are neutral in nature, okay. Now how the pH scale is come? See, pH scale is between 0 to 14. Why 14? Why not behind 14? Okay, above 14 like 15, 16. So for that concept we have to know the whole formula, that is pH plus pOH is equal to 40. This is must you know, okay. How this is came? This is came from, see, water has ionic product like H plus plus OH minus. you can just see water have both H plus ion and OH minus ion, and dielectric constant, okay, dielectric constant of this water is nothing but 1 into 10 raised to minus 40. So what is the, see this is combiner, so we have 1 into 10 raised to minus 14 and we have same H plus ion, OH minus ion in same extent, therefore we have to divide 1 into 10 raised to minus 7 and 1 into 10 raised to minus 7 for OH minus ion. Okay, so we have the ionic product of water. Okay, so now if I take you can see like this is nothing but the dielectric constant, and not going so much depth, you have to just know this formula, that is pH plus pOH is equal to 40, and we have to derive this. Okay, so time is very less, therefore we have derived this formula in the next lecture. Okay, thank you. So we try it in next lecture tomorrow. Okay.